Konnichiwa minasan. Hey friends, how are you? Welcome to SARAL JAPANI YouTube channel. Today we are starting a new series dedicated to solving the previous year's question papers of MEXT written tests in various subjects for the undergraduate admissions. This particular playlist is dedicated to Mathematics A exam, and this particular video, which is first of the series, is about solving the Math A 2020 question paper. So if you are preparing for the MEXT scholarship or university entrance in Japan, this is the perfect place to sharpen your math skills. So let's dive straight into the first question of 2020 question paper and take it from there. So this is the first question. Answer the following questions and fill in your responses in the corresponding boxes on the answer sheet. So a separate answer sheet will be provided, and you can see here this is the first part of the first question. That is the first sub question, and here you can see one block 1-1. So that means this is question number 1-1. So 1-1. This is here. So on the answer sheet where 1-1 is written, so on that area you will have to write the answer to this question. So there are basically 9 questions under this question number 1, and today we are going to solve the first 6 questions of question number 1. So of all, there are around 11 or 12 questions for which you have to answer in 1 hour time. So out of those 12 questions, 9 are part of question 1, and then there are question 2 and 3 where they also have some subparts. So in totality, there are around 12 to 15 questions which you have to answer in 60 minutes. So let's begin with the question number 1-1. For sets A, B, and C. So this is a question of set theory. For sets A, B, and C, we assume C belongs to A. The number of elements in set A is 66. That in set A, but not in set C, is 47. That in set B, but not in set C, is 42. And that in set C, but not in set B, is 8. And that in set A, but not in either set B or set C, is 31. Then the number of elements included in set A, B, or C is what? This is the question. So if you read the question like just like that, just like I read, it may sound very, very confusing because there are so many conditions given. So it is very difficult to visualize. So let's start solving this step by step. So let's summarize what has been asked. For sets A, B, and C, we assume C belongs to A. Then you can write like this: number of elements in A is 66, elements in A but not in C 47, in B but not in C 42, in C but not in B is 8, and number of elements in A but not in either B or C is 31. So what is our aim? Our aim is to find the number of elements included in set A, B, or C. So A, B, or C, what does that mean? That means A union B union C. So you have to find the number of elements present in A union B union C. So using all these given conditions and applying the concepts and formulas of set theory, you have to arrive at the value of number of elements of A union B union C. So first we start with the given condition that C belongs to A. That means whatever is there in C also part of A. Now from the given value that the number of elements in A is 66 and the number of value in A but not in 66 is 47. So from these three conditions we can straight away say that the number of elements in C is 66 minus 47 because C belongs to A and we have A without C. So straight away C will be A minus this 47. So 66 minus 47, it is 19. Now next come to the next criteria, that is C, number of elements in C which are not in B is given to be 8. So that means the intersection intersection B will be 19 minus 8 because 19 is C and 8 is C but not B. So that means C intersection B will be 11. Now the next given criteria is that elements in A but not in either B or C is 31, the last criteria. So we can write A as the disjoint union. So this is from the set theory formula. The disjoint union formula, we can write a set A is equal to A which is not present in either B or C is the disjoint union of a set which is formed by A intersection B which is not part of C and again disjoint with C. So this is nothing but A. So this is from the concept of disjoint union of set theory. If you expand, you will definitely arrive at A because there will be several combinations which will yield 0 and ultimately just A will remain. So now we have all these values except for one, this expression A intersection B not present in C is the unknown one. Otherwise A is 66 we know. A but not B union C is 31 we know, and C we have found out to be 19. So from this we can find that A intersection B which is not part of C is 16. Now number of elements in B which is not part of C is 42. It is also given and we can write it as A intersection B which is not present in C plus B which is not present in A union C as 42. This is again from the set theory formula. So now we have the values for A intersection B not present in C which is 16, and then we consider this B not present in A union C as Y. We just assume it. So from that Y is 26. So that means this value is 26. So 26 is the number of elements in B that are neither in A nor C. Now because C belongs to A, so we can easily write that the number of elements in A union B union C, that means either A or B or C, is equal to the number of elements in A plus the number of elements in B which are not present in A, and which from this we get 66 plus 26 because 26 is this one, B which is not present in A union C, and 66 we have from A which is originally given in A. So total is 91. So the total number of elements in A, B or C is 92. So this is the final answer of this question. So this is very simple question actually. If you know these formulas, these relations, if you can expand or if you can express in this way, then it is not difficult to solve this problem, and you have to be very uh, you need to have these concepts of set theory very clear in your mind, because in exam in this test you will get just 1 hour, so you don't have on an average more than 5 minutes to solve each question. So remember that. So there will be around 12 to 15 questions. So at max you can devote 5 minutes for one question. So for that to happen, you have to be very fluent and very comfortable with all these concepts so that you can immediately apply these concepts. Otherwise, you will get stuck and one question itself will take 15 to 20 minutes, and in that way you will not be able to answer many questions. Let's move on to the next question. This is the second question, which is related to the graph theory. So several questions are asked. So as and when we keep solving, we move on in solving these papers, you will realize that certain topics are asked very frequently. For one is the set theory that we have just seen, the other one is the graph theory. So there will be multiple questions on graphs. This is the question number 2, 1-2. Consider a graph of the function y is equal to x square in the xy plane. The minimum distance between point 0, 4 on the y-axis and points on the graph, that means this graph y is equal to x square, is dash. you should rationalize the denominator in the answer. So that is the secondary thing. But the first thing is that you have to find the minimum distance between a point on the y-axis, which is represented by 0, 4, and the points on this graph y is equal to x square, which is a parabola, isn't it? Y is equal to x square is a parabolic graph. So you have to find the minimum distance between this point 0, 4 to this graph y is equal to x square, and that should be the answer to this question. So now let's see how to solve this problem. So we need to minimize the distance. Our aim is to minimize the distance from 0, 4 to a point x comma x square on the parabola. Why this is x comma x square? Because this is represented as function of x comma y. So x is x and y is x square. So that's why, since this is an xy plane, so it will be, the generic expression will be x comma x square will be a point on the parabola. So we want the distance from the fixed point 0, 4 to a moving point on the parabola q x, which is represented by x comma x square. So this is what we know and what is given in the question. So now we need to use the very fundamental distance formula. For any two points x1 y1 and x2 y2, the distance between the 2 points can be given by d is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. Here x1 is 0 here, okay, and y1 is 4, and here x2 is x and y2 is x square. So we can replace these values in this formula and we can get dx equal to square root of x minus 0 whole square plus x square minus 4 whole square, and this will lead us to dx equal to root over x square plus x square minus 4 whole square. Now here comes the differential calculus, because we know that differential calculus can be used in case of quadratic equations, and the using differential calculus, a quadratic equation can be reduced to a linear equation, that you know already from the concepts of differential calculus. So this is one application where we can use the differential calculus, because we have this in square. So since it is very difficult to solve in square, so we can find the derivative using differential calculus, and that will make our calculations very easy. So because the square root is increasing, minimizing the square also minimizes the original distance. So instead of minimizing dx, we minimize d square x. So we have d square x is equal to x square plus x square minus 4 whole square. This is from here. If dx is this, then we can write dx square as this. So this is how we get dx, this expression. Now we perform differentiation. Differentiate and set to 0. That means ddx of d square x is equal to, now what will be the derivative of this? So from the differential calculus formula, we know that if it is x square, it will become 2x. The power will come in front of that and it will be x. One exponent will be less. Similarly, x square minus 4 whole square will become 2x into x square minus 4. This is again from the formula of differential calculus. And together, after simplifying, it will give you 2x into 2x square minus 7 equal to 0. So x equal to 0, from this we have x equal to 0, either x equal to 0 or x square is equal to 7 by 2. Evaluate d square at these critical points. These are known as the critical points. So now if you put x equal to 0, then we have d square is equal to 16. And if we put 7 by 2, then d square plus minus root over 7 by 2, which will give us 15 by 4. So the minimum distance is, d minimum is square root of 15 by 4. So since we found out d square, so d will be now root over 15 by 2. Okay. Sorry. Yes. So the minimum distance d minimum is obtained as root over 15 by 2, and this is the answer. Denominator is already rational, so the answer is in rationalized form only. So the square root of 15 by 2 is the answer to this question. That means this is the minimum distance between the point 0, 4 on the y-axis and the points on the graph y is equal to x square, which is a parabola. Next, moving on to question number 3. Again, a graph theory question. Consider a graph of the function y is equal to 2x square minus 6x plus 2 in the xy plane. Next, consider another graph that is symmetrical to the previous graph with respect to the line x equal to 2. The graph that is symmetrical to the latter graph with respect to the line y is equal to 3 is described as y is equal to a2x square plus a1x plus a0. Then we have a2, a1, a1 and a0 as what? So you have to find the values of a0, a1 and a2. But one thing you should be very careful is that in the first criteria it's given that this graph should be symmetrical. Consider another graph that is symmetrical to the previous graph with respect to the line x equal to 2. And then the graph is symmetrical to the later graph with respect to the line y is equal to 3. So there are two conditions basically. So how to solve this one? Let's see now. So the original function. So let's summarize what are all given. Original function is y is equal to twice x square minus 6x plus 2. A graph symmetrical to this original graph with respect to the line x equal to 2, and then a graph symmetrical to the graph in step 2 with respect to the line y is equal to 3. So it is going away from the original graph. So at step 3, the graph that we are talking about in step 3 is not with respect to this original graph, but it's respect to the graph which we got in step 2. So the step 1 will be of to find the graph symmetrical to the original graph with respect to x equal to 2. Now symmetry about a vertical line x equal to k, where k is a constant, means that if xy is on the original graph, then 2k minus x comma y is on the symmetrical graph. Okay, so this is from the symmetry concepts of symmetry. It will be 2k minus x, and here k is equal to 2. Since x equal to 2, so here we can assume that k is equal to 2. Now if the original function is y is equal to fx is equal to 2x square minus 6x plus 2, then the new function symmetrical about x equal to 2 will be y is equal to function of 2 into 2 minus x, which will be function of 4 minus x. So we have to calculate f of 4 minus x, which is equal to twice 4 minus x whole square minus 6 into 4 minus x plus 2. So expanding this, we have this. So this is a simple expansion, and then we simplify, and we finally arrive at 2x square minus 10x plus 10. So the equation of the symmetrical graph about x equal to 2 is y is equal to 2x square minus 10x plus 10. The next step is to find the graph symmetrical to the graph from step 1 about y is equal to 3. So now the line is y is equal to 3, but we have to find a graph symmetrical to the graph from the previous step. So symmetry about a horizontal line y is equal to c means if xy is on the original graph, then x comma 2c minus y is on the symmetrical graph, isn't it? So here c is equal to 3. Given the function y is equal to gx is equal to 2x square minus 10x plus 10, the symmetrical graph about y is equal to 3 satisfies y is equal to 2 into 3 minus gx, which is 6 minus gx. So now we need to substitute gx. So substituting gx with the expression y is equal to 6 minus within bracket 2x square minus 10x plus 10 is equal to 6 minus 2x square plus 10x minus 10. And we finally, after simplification, we get this equation: y is equal to minus 2x square plus 10x minus 4. So the final form which is given in the question is y is equal to a2x square plus a1x plus a0, and what we have found is y is equal to minus 2x square plus 10x minus 4. So we can directly consider the coefficients here, and we can simply write that a0 is minus 4, a1 is 10, and a2 is minus 2. So the answers are minus 2, 10, and minus 4. So in this way you have to solve the problems which are asked related to the graph theory. So again, this is not a difficult question, but you should know how to find the solution. That's all it matters. Next is question number 4. So this question is from the topic of inequalities. So let x and y be integers. We assume that x plus y is a multiple of 2. So this is a very useful criteria. Then x plus 4y is less than or equal to 17, and 3x plus 2y is less than or equal to 19. Then x plus 2y is having maximum when x is equal to dash and y is equal to dash. That means you have to find the maximum value. So it's maxima minima concept, and yes. So let's look into the solution and approach it step by step. So let x and y belongs to z, which is the set of integers, and we assume that x and y satisfy the following conditions. X plus y is even. This is given because it's a multiple of 2. X plus 4y is less than or equal to 17, and 3x plus 2y is less than or equal to 21. Determine the integer values of x and y for which the expression x plus 2y is maximized. So this should be our aim, because it is mentioned in the question that x plus 2y is maximum when x value is this and y value is this. So determine the integer values of x and y for which the expression x plus 2y is maximized. It is also given that x belongs to 1 comma 7 and y belongs to 1 comma x belongs to 1 comma 6 and y belongs to 1 comma 7. So let's start with analyzing the constraints. The step 1 is analyzing the constraints. Since x plus y is even, the sum of x and y must satisfy x plus y. The modulus is, the remainder is 0. That is modulus is 2, remainder is 0. This inequality, the inequality constraints restrict the values of x and p. X plus 4y less than equal to 17 and 3x plus 2y less than equal to 21. The variables x and y are integers, with x lying between 1 and 7 and y lying between 1 and 8. The inequality constraints restrict the values of x and y. X plus 4y less than equal to 17 and 3x plus 3y less than equal to 21. The variables x, y are integers, with x lying between 1 and 6 and y lying between 1 and 7. Okay. So let's move forward. Then step 2 is to express the feasible region for a fixed integer x and y. For fixed integer y, the x must satisfy both inequalities. That is, x is less than equal to 14 minus 4y, and x is less than equal to 21 minus 2y by 3. So this we have deduced from the previous equations or the given inequalities. Hence x is less than equal to minimum of 17 minus 4y comma 21 minus 2y by 3. So it comes directly from here. So now we have to prepare a table like this by having the values of y from 1 to 7 and then correspondingly finding the values of 17 minus y and 21 minus 2y. So we can see here when y is 1, 17 minus 4y is 13, 21 minus 2y by 3 is 6.33, minimum value is 6.33, maximum integer with x less than equal to minutes, minimum is 6. So in this way, for each value of y, we need to find this value. Okay, in this way. And then for each y that we found out, find the largest integer x satisfying the above bounds and such that x plus y is even. So that means all the values that we get may not be valid because the condition is given is that x plus y should satisfy the criteria that x plus y is even number. Because if we add two even numbers, the result will also be an even number. So when y is equal to 1, max x is 6, but 6 plus 1, that means x plus y is 7, which is odd. So we have to use 5 giving 5 plus 1, which is 6, which is even. So for this one, we have to set x as 5. Okay. Similarly, when y is equal to 2, max of x is 5, but 5 plus 2 is again 7, which is odd. So use x equal to 4, giving 4 plus 2, which is 6 or even. So similarly, when y is equal to 3, max x is 5.5 plus 3, which is 8. This is even, so this is fine. Y is equal to 3. So it is 5. So 5 plus 3 is 8. When y is equal to 3, maximum of x is 5 and 5 plus 3 is 8, which is even. So this is a valid entry. Now when y is equal to 4, max x is 1. 1 plus 4 is a 5, which is an odd identity. So use x is equal to 0 minus 0 plus 4, which will give you 4 as even. Then we have y is equal to 5, where max x is minus 3. Minus 3 plus 8 is 2, which is even, and this is again valid. Y is equal to 6 gives us max x is equal to minus 7. Minus 7 plus 6 is minus 1, which is odd. So use 8 instead. That means in place of 7 use 8, so it will give us minus 8 to 8 plus 6, that is 2, and y is equal to 7, x equal to minus 11 will give you minus 11 minus 7, minus 11 plus 7, which is minus 4, which is still a valid number. So this is the final table. Evaluate objective x plus 2y for valid pairs. Now the valid pairs we got from the previous step. So here we have to find the value of x plus 2y by putting the values of x and y. So we know from the previous table that when y is equal to 1, x chosen is 5, and this gives x plus 2y as 7. Similarly, 2, 4, 8, 3, 5, 11. And why we have circled this one, I will just tell you. Before that, 4, 0 and 8. 5 is minus 3. So minus 3 plus 10 is equal to 7 and so on. And we see from all these values that the maximum value is 11. And so the numbers corresponding to this maximum value 11 are your. Okay. So when y is equal to 3, x equal to 5, x plus 2y will be 5 plus 6 equal to 11. So this is from this list you can see that this is the highest value in this series. So this is the maximum value. So the maximum value of x plus 2y is 11, and which is achieved at x equal to 5 and y is equal to 3. So this is the final answer. Now again another question of graph theory, question number 5. Consider two graphs of the functions y is equal to 1 by 8 x square minus 2 and y is equal to 1 by 2 x square minus 8 in xy plane. So friends, can you tell me what shape will these graphs indicate? Like which geometrical figure will be created by plotting the graphs represented by y is equal to x square by 8 minus 2 and y is equal to x square by 2 minus 8? These will be parabolas. Yes, correct. This is parabola. So we describe a common tangent line of the two graphs in xy plane as y is equal to a1x plus a0. So this, as you know, is the basic equation of a straight line where a1 is the slope and a0 is the intercept. We assume that the x coordinates of both tangential points are positive. Then we have a1 is equal to what and a0 is equal to what. That means you have to find the slope and the intercept of the tangent line to the two parabolic graphs. This is our intention. So we have two parabolas, y is equal to x square by 8 minus 2 and y is equal to x square by 2 minus 8. We are looking for a common tangent line to both curves with the tangent line expressed as y is equal to a1x plus a0, where the points of tangency on both curves have positive x coordinates. And we want to find a1 and a0. So this is the problem statement of this question. So next is we write the tangent lines to each parabola. So for parabola 1, y is equal to x square by 8 minus 2. Its derivative is f1 dash x is equal to 1 by x, 1 by 4x. How it is coming? You know from the differential calculus, 1 by 8 is there multiplied by 2x, twice of x is the derivative. So 2 and 8 gets cancelled and it remains 1 by 4x. So in that way, and also the derivative of 2 is 0, so this portion goes out. So f1 dash x is 1 by 4x. This is the derivative of this expression. At tangent point x equal to t1 equal greater than 0 as mentioned in the question, the tangent line will be, we can describe it as y is equal to 1 by 4 t1 multiplied by x minus t1. So why this kind of, this is the slope. Okay, since we are considering this tangent point x as t1, that means the point where it touches the parabola, the straight line touches the parabola. So at that point it will satisfy this expression, y is equal to 1 by 4 t1 into x minus t1 plus 1 by 8 t1 square minus 2. That means we are simply substituting x with t1. So this is the 1 by 8 t1 square minus 2, which becomes the intercept, and 1 by 4 t1, this is 1 by 4x, so 1 by 4 t1 multiplied by x minus t1, this is the slope, and it based on the equation of a straight line. So now simplifying, we can simplify this expression and we get 1 by 4 t1x minus 1 by 8 t1 square minus 2 equal to y. Similarly, for parabola 2, we have y is equal to 1 by 2 x square minus 8, and its derivative will be x only, because x square it is 2x divided by 2, 2 gets cancelled, so it's just x, 8 is 0, so just x. Now at tangent point x equal to t2 greater than 0, the tangent line will be given by y is equal to t2 into x minus 2 plus half of t2 square minus 8. So from these two we can write the equation of a straight line like this. So one is this function, the other one is the derivative of that function, which incorporates the slope. So further simplifying this, we get y is equal to t2x minus half t2 square minus 8. Now next step 3 is, since this is a common tangent line to both the parabolas, both must be equal. That means using this y is equal to a1x plus a0, and a1 is equal to 1 by 4 t1 is equal to t2, and a0 thus becomes minus 1 by 8 t1 square minus 2, which is minus, further simplifying, minus t2 square by 2 minus 8. So set the slope equality. Now we have two equations or two values. Setting the slope equality, a1 is 1 by 4 t1, which is equal to t2. So t2 is 1 by 4 t1. So a0 is t2 minus t2 square by 2 minus 8, and a1 is t1 by 4. Now set the intercept equality. That means equating the two intercepts that we have found. So minus 1 by 8 t1 square minus 2 is equal to minus 1 by 2 t2 square minus 8. Now in the previous step we got t2 is equal to t1 by 4. So we substitute that in this equation and we get minus 1 by 8 t1 square minus 2 is equal to minus 1 by 2 multiplied by 1 by 4 t1 whole square minus 8. And when we simplify it, we arrive at this point, bringing all terms to one side. So this is just arithmetic, subtraction, multiplication, subtraction and addition, and from this we finally arrive at minus 3 by 32 t1 square is equal to minus 6, and from this we get t1 square is equal to 64. So therefore t1 is square root of 64, which is 8, which is a positive root since t1 is greater than 0. So t1 is found now. Now find t2. T2 is 1 by 4 t1, so it will be straightforward that 8 by 4, which is 2. So now we are in a position to find the coefficients a1 and a0. a1 is equal to t2 is equal to 2, and equivalently a1 is equal to 1 by 4 t is equal to 1 by 4 into 8a. Now calculate a0. a0 is minus 1 by 8 t1 square minus 2, which is equal to minus 8 into 64 minus 2, and which is finally equal to 8 minus 2, which is minus 10. So minus 10 is the answer, Kaustav, to your question. So the final answer is a1 is equal to 2 and a0 is equal to minus 10. Number 6, question number 6. This is question number 6 of main question 1. When we set t is equal to cos x for a function fx is equal to cos twice x plus cos thrice x, fx has an expression in t as follows: dash t3 dash t cube plus dash t square plus dash t plus dash. So what will be the values in the blanks, these blanks? So when you encounter such type of question that in trigonometrical form one expression is written, whereas in the question they have given some higher order polynomial like t cube, t square, t, then you have to think the best way to express these cos sine things also in the square format. So using Chebyshev polynomials or multi-angle formulas, you can recall these formulas. Cos twice x is equal to 2 cos square x minus 1, and 3 cos thrice x is equal to 4 cos cube x minus 3 cos x. So these are very standard formulas which you should memorize. So now in the question they have written that t is cos x. T is cos x. So if t is cos x, then cos square x will be 2t square minus 1, and 4 cos cube x minus 3 cos x will be 4t cube minus 3t. So combining this and these relations. So we can now substitute into fx. So fx is equal to cos twice x plus cos 3x is equal to 2t square minus 1 plus 4t cube minus 3t. So this is just simplifying or expressing cos twice x and cos thrice x in higher order polynomial so that we can arrive at the in the form of this expression. So we get substitute into fx. So fx of cos twice x plus cos 3x is 4t cube plus 2t square minus 3t minus 1. So from this, if we now compare, we can easily say that this value is 4, which is 1 dash 11 question number. Question number 1 dash 12 is 2. Then it is minus 3 here, and this is minus 1. So this was a very, very easy question which you should not take even 5 minutes, because the previous question to that was little lengthy one. So you have to maximize your output, to maximize your answering and your number of answers. You should be very quick with the easier questions. So friends, that's all for now. So we solved 6 questions of Mathematics A 2020 question paper, and the remaining 3 questions of question number 1 and 2 more questions, question 2 and question 3 of MEXT 2020 Math A paper. We will do that in the next part of the video. So in the next video of this playlist, we will cover the remaining questions of 2020 question paper of Math A. So I hope if you are solving this question paper and you found it difficult to solve, then this video will help give you some kind of direction. Again, I am reiterating that the questions are not difficult. They look difficult, but actually they are not, if the concepts are very clear in your mind and if you can recall the things, recall the appropriate things at the appropriate place, which is required for such type of tests. So thanks for watching this video. I will be soon back with the rest of the questions solved for you to practice. So if you have any questions, or if you didn't understand something in the 6 questions that we discussed, you can send me an email at saraljapani@gmail.com, and I will be happy to explain you in more details. Yes, that's true. If you are stuck or if you could not understand a particular step in any of these problems, just write the question number and the particular step that you did not understand, and I will get back to you over email. So thanks for watching. Till we meet again. Mata imasho.